This video is on the organelle called the endoplasmic reticulum, or ER. The ER is a system of membranous tubes and sacs called cisternae, again with the phonetics cisternae. Now, the main function of the ER is to act as a path that molecules move from one part of the cell to the other, and the amount of endoplasmic reticulum depends on the cell's activity. There are two types, rough and smooth, and there's two differences between rough and smooth. Number one, rough has ribosomes, that's why it's called rough, and smooth endoplasmic reticulum has no ribosomes. And two, I described it as a system of membranous sacs and tubes. The rough the rough ER is the sacs, and the smooth ER is the tubes, which you can see from the diagram here. Sac means like a kind of a bag type structure. So imagine you've got like a balloon that's like squished. That's what a sac is. And you can see from the smooth endoplasmic reticulum that it is a system of tubes. So rough endoplasmic reticulum has ribosomes, and those are sacs. The smooth, no ribosomes, and they are tubes. The rough and smooth ER have different functions. So the rough ER is a system of interconnected flattened sacs that are covered with ribosomes. Their function is to produce phospholipids and proteins. You can always find the rough ER directly surrounding the nucleus, which you can see from this diagram here, where the nucleus is right here, and surrounding right outside of the nucleus is the rough ER. And this is what I talked about in the previous video when I did about ribosomes, that when ribosomes are going to make proteins that are going to be exported, they go straight from the nucleolus to the rough ER that's right outside of the nucleus. And you can see here that ribosomes go in and they get modified or whatever, and then they come out as a modified protein. Certain proteins are made on the rough ER's ribosomes. Like I said before, these are the proteins that will be exported from the cell, or they might be inserted into the cell membrane as an integral protein. The cells where you find the most rough ER, where they're the most abundant, it means that these cells are producing large amounts of protein for export. Again, the structure is because of its function. Form follows function. If the function of a cell is to produce proteins to be sent out of the cell, you're going to find lots of rough ER there, because that's the whole function of the rough ER. The smooth ER is a little bit different. One, it lacks ribosomes. Most cells have a very little amount of smooth ER, and you can see rough ER here compared to the smooth. Again, these are sacs. Smooth ER is the tubes. It's all outside of the nucleus, and you can see ribosomes on the outside, and here no ribosomes. Large amounts of rough ER, small amount of smooth. The smooth ER does a lot of different things, and you don't have to remember all of them. But giving you some examples, they build lipids like cholesterol. In the ovaries and the testes, the smooth ER produces the hormones estrogen and testosterone. In skeletal and heart muscle, the smooth ER in the cells release calcium, which stimulates those muscles to contract. And in the liver and the kidney cells, the smooth ER helps detoxify drugs and poisons. Now that's the main function of both the kidneys and the liver, is to filter the blood of waste products and toxins. Now, relating to the liver, long-term abuse of alcohol and drugs are going to cause the cells to produce more smooth ER. And an increased amount of smooth ER in the liver cells leads to what's called tolerance, which you probably, if you haven't already, you will definitely learn in health class. That's, tolerance is when you build up kind of an immunity to the effects of drugs and alcohol. So I'll just use alcohol as an example. Maybe the first time that you have a glass of wine or your first beer, um, it has a very big effect on it because you don't have a lot of smoothie R in your liver cells. But if you abuse that, like on a daily basis or a regular basis over a long period of time, because alcohol has so much toxins in it, it actually, the alcohol gets broken down by your liver cells to form formaldehyde, which is what we use to preserve dead organisms, like formalin. I'm sure you've heard of formalin. That's a brand name, or I think a brand name, or a certain uh, version of formaldehyde. And that's what alcohol gets turned into by your liver. So that's not good, right? You don't really want to build up a preservative chemical in your liver. And also, your liver doesn't actually ever get rid of waste products like your kidneys do. Your kidneys filter your blood of waste products, but then it sends it all to the bladder and you get rid of it through your urine. But your liver just kind of takes it out of your blood and just collects it. So that's why if you have years and years and years of alcohol abuse, you end up with a disease called cirrhosis, which is like you've literally destroyed your own liver because the liver can't clean itself. Um, Also, I would say in this day and age of like the internet, especially social media, and there's so many weird posts of especially about health and non-medical remedies, when you see advertisements for like detoxing, or like, you know, you drink this tea and it helps cleanse your liver, there's only one like detox. There's only one way for your body to detox, and that's just by having a liver. We all have a liver. That's the way that we detox. There's no drinks or smoothies or herbs or whatever that's going to detox your body for you. That's what your liver does. So anyway, the point being, because if your body is exposed to alcohol, lots of alcohol over a long period of time, in order for your body to try to combat that and help your liver filter that out of the blood, it creates more smoothie R. But then having more smoothie R means that maybe not one glass of wine, maybe it takes a bottle of wine now instead, to have the same physical effect on you. That like instead of one glass getting you drunk, it takes a bottle. And the longer you abuse it, the more it takes. And the same thing happens with drugs. If you take drugs the first time, you get super high and you're like, woo. But if you keep taking it, it takes more than just one time or like one small amount. It takes more and more because of your smoothie R.